Okay. So like I said, the review for today is in the folder. We're in sections 5.3 and 5.4. So taking a look specifically at graphing and some different characteristics of polynomial graphs. All right. The review looks like this. And we're going to go through the odd problems as a class, and then whatever we do not get done will be due for homework. So all of the even questions are yours to complete as extra review for tonight. Okay. This first section, so we're actually going to skip part C, but this first section, we want to write the expression in standard form. Remember, that's always kind of the first step in our process, is to make sure our polynomial is in standard form. And then we want to classify the function based off of the degree and number of terms. So remember that we had certain words that we use to describe a polynomial based off of the number of terms it has and the highest degree that we see there. All right. So for example 1, how would I write this in standard form? What would be standard form of this example here? Good. X cubed minus 2x minus 3. I write it in descending order based off of its powers, so each of the exponents there. My degree of this is what? What's the degree of this polynomial? 3. And if it's of degree 3, what's that word that I would use to describe that? If something's to the second power, it's squared. If something's to the third power, it is cubed, right? So you would call it a cubic. And then I have 3 terms. If I have 3 terms, what's that word that I used to describe something, a polynomial of 3 terms? Good, trinomial. Odd. So a cubic trinomial, right? Just kind of getting into the habit of putting something into standard form and then understanding how we would classify that based off of the degree and number of terms. All right. You're going to do something very similar in number 2, just put it in standard form and then describe it using those specific words to categorize. All right. Any questions about number 1? Okay. This second section here for numbers 3, 5, and 7, we're given a polynomial equation, and based off of that, we need to determine the end behavior. Now, end behavior was that asynchronous day on Friday. It was in that video. So if you have not done so already, please make sure that you watch that video and also complete the homework assignment if you have not done so already either. In the video, we talked about just being able to determine what the end of my graph is going to look like based off of the exponent, the highest exponent, so the degree of the polynomial, and the leading coefficient, right? And we created this chart for us that I'm going to recreate now. And I would suggest that you write down, I would take a picture of this if you need to kind of use this to your advantage to study for the quiz tomorrow. There was a situation where if we had an even degree or an odd degree, that was going to change the shape of our graph and what that looked like with our end behavior. And we also needed to pay attention to whether our leading coefficient was positive or negative. Okay. So that's what we need to keep an eye out for, is whether or not our degree of our polynomial is even or odd, and then whether the leading coefficient, so the number in front of that, is positive or negative. Okay. In each of these, and what you're going to see tomorrow on the quiz, it'll say as x approaches negative infinity, what is y doing? As x approaches positive infinity, what is y doing? So essentially that's saying as I go to the far right on my x-axis, is my y values, are they increasing or decreasing? As I go to the far left on my x-axis, so as I approach negative infinity, is my values increasing or decreasing? All right. If it was even and positive, they're both increasing. So this is what it kind of looks like if it's even and positive. If it's even and negative, they're both decreasing. So this is a visual example for you. And we're going to use our positive and negative to answer these questions, but just so we're aware of what it would look like. If it was odd and positive, my graph looks something like this. Odd and negative is the opposite. So it looks something like this. Okay. So you have a visual cue now of what it should look like based off of your equation. And hopefully this will allow you to answer questions like, as I approach X in the positive direction, what's happening to my Y's, and vice versa. Okay. So we're going to go through examples 3, 5, and 7 now and ask ourselves each of those questions. So as X approaches negative infinity, what's my Y doing? As X approaches positive infinity, what's my Y doing? All right. Based off of the equation we're given. So in example 3, what is the degree of my polynomial? Is it even or odd? Odd, right? Because it's to the third power. Somebody from home, help me out with this. Is my leading coefficient positive or negative?
Positive.
Positive, good. So if it's odd and positive, what I would do if I were you is recreate this chart and go to it and say, okay, well, as X approaches positive infinity, so as I move in this direction, where are my Y's going? Are my Y's increasing to positive infinity or decreasing to negative infinity? Positive infinity, good. Right? As you move to the right, this graph's continuing in this positive Y direction for forever. So it's increasing to positive infinity. What's happening if it's going in this direction? So if it's odd and positive and I'm going towards, or I'm sorry, hold on a second. So we answered the positive infinity first, my apologies. As I'm going towards negative infinity, so if I'm going in the left direction, where's my Y going? Towards positive or negative infinity. It's going down, right? So it's going towards negative infinity. Right? If it's going up, that's positive infinity. If it's increasing, if it's going down, that's negative infinity. That's decreasing. Okay. Any questions about example 3? Example 5. What's the degree of my polynomial? Is it even or odd? Odd. And what's the leading coefficient? Negative.
Odd.
Right? Sorry, was that what you were going to say?
Yeah.
Sorry, I didn't mean to jump the gun there. So odd and negative. So again, I'll go to my chart here, odd and negative. Well, as my graph is approaching negative infinity, so let's do it in order this time. My apologies. As my graph's approaching negative infinity, so it's going to the left. What is my graph doing? Is it increasing or decreasing? Increasing, so it's going towards positive infinity or negative infinity? Positive, good. As my graph is going towards positive infinity, what is my Y, or what are my Y values doing? Are they increasing or decreasing? Decreasing, so my graph is going towards positive infinity or negative infinity? Negative infinity. Good. Any questions about number 5? Last one, somebody from home. What is the degree of my equation in number 7? Even or odd?
Odd.
Good, it's odd. And the leading coefficient, is it positive or negative?
Positive.
Positive. So we'll go to our chart again, odd and positive. As I go to X in the negative direction, Is my graph increasing or decreasing?
Decreasing.
Decreasing. So is it going towards positive infinity or negative infinity?
Negative infinity.
Negative infinity. Good. As it approaches x in the positive direction, is it increasing or decreasing?
Increasing.
Increasing. So it's going towards positive infinity, right? Good. Any questions about end behavior, any of these examples? Again, like I said, I would suggest putting this chart down so you have a visual example. You also are able to answer questions about end behavior based off of the degree and the leading coefficient. And you would be good to go for those types of questions. Yeah, I'll do one with an even. So if we take a look at number 6, okay? So again, we'll ask ourselves, and how it's going to be posed tomorrow is, as x approaches negative infinity, you're going to fill in the y. As x approaches positive infinity, you'll fill in the y again as well. So as x approaches negative infinity, I have an even degree, right, in number 6. What is my leading coefficient? 4, which is a positive or negative number? Positive. So I'll go even positive, all right? And we're going to ask ourselves the same question. As I go to negative infinity in the x direction, where's my y going? Positive infinity. And as my x goes to positive infinity, in that, what's that? No, not quite. Positive. So one thing that is unique about the even functions is that they're going to go in the same direction. So if it's positive and even, they're both going positive infinity. If it's negative and even, they're both going towards negative infinity. Right? So kind of just take a look at those graphs there. Notice that they're going in the same direction each time. The odd functions, one's going up, one's going down. All right. So if you're given an odd function tomorrow and you come out with the same answer on your y's, it's probably not going to be correct, right? But if it's even tomorrow and you have the same, it's going to be correct, right? So long as you know if it's positive or negative. Yeah, so you're going to be given tomorrow, x approaches negative infinity, x approaches positive infinity. You just have to fill in the y. So you're just telling me what the end behavior is there. Okay? Any questions about end behavior before we move on? All right. We're going to do example 9 together. For this particular problem, it says, given the polynomial equation, determine the location principal zeros, right? So finding the zeros of a polynomial equation. Tomorrow you'll be given a chart here, so you don't have to worry about recreating that and choosing your own x values. What would I do to find the f of x values here in the bottom of my row? How would I start a problem like this? What do I have to do with these x's? Anybody from home have any ideas? What do I have to do with those x's that's in my table?
You have to substitute them for the x in the equation.
Right, just plug them into the equation. Good. So I'll take the -3, plug that in, -2 times -3 squared, -3 minus 2. -3 to the 4th power is 81. What's -3 squared? +9. What's 9 times -2? -18 minus 3 minus 2. And then that's going to give me, so 81 minus 18 minus 3 minus 2 is going to give me +58. Now, I just showed that by hand, but what I would suggest doing is having a calculator nearby for tomorrow's quiz. So you are able to plug these values in. You'll get your Y values in a much quicker and easier, a little bit more efficient time than having to write all of these out for every single term, okay? So it's plus a -3, right? So it's -3, right? But if you don't have a calculator and you have to do this, make sure that you're showing your work. So if I have to plug in a -2, -2 to the 4th power minus 2 times -2 squared minus 3, or minus, excuse me, 2 minus 2. What's -2 to the 4th power?
Is it 16?
Positive 16, good. -2 squared is positive 4 times -2 is -8, minus 2 minus 2. Well, 16 minus 8 is 8, minus 2 is 6, minus another 2 is positive 4. You would continue this process for all of your values, right? If you plug in -1, you get -4. If you plug in 0, you get -2. If you plug in 1, you get, I'm sorry, 1 to the 4. I think I miswrote something down here. -2. 2, you get 8. 3, you get 64. Yeah, okay. So you would get those values by plugging them into your equation and then just simplifying. Well, we're asked to find these zeros. Okay, my first question for you is, are there any zeros that are apparent in my f of x right now? No, right? There's no zeros in there. Good. So then what do I have to look for if I don't have any zeros in the f of x? Right. So the transition from a positive y value to a negative, or a negative to a positive, right? Because what does that mean my graph's doing? What's it crossing? The x-axis. Awesome. So as I look across my y values, I'll go from positive 58 to 4. So it's positive, positive, positive to negative. My answer, what I'm going to write for the zeros, is the x values that's between. So I'll say the first 0 is between x is equal to -2 and x is equal to -1, right? Because that's where I make that transition from positive 4 to -4. So it's between -2 and -1. Good. So then the follow-up question would be, well, where's my next 0? And as we said here in class, it would be between x equals 1 and x equals 2, positive 1, positive 2, because that's when I go from -2 to positive 8. That's between the values of 1 and 2. So I'm making that transition from a positive to a negative and vice versa. Sometimes it'll have to be that way, or there will be a 0, given to you, right? In which case that would be your 0. Okay. Any questions about number 9? Number 10 is very similar. You would just have to choose those values to plug in, fill in your table, and then find your zeros that way as well. Okay. The last question that we're going to look at is number 11. All right. There's quite a few things that we need to figure out for number 11. The first thing we're going to do is very similar to what we did in the last example. We're going to fill out our table by plugging in our values. Again, like I said, tomorrow on the quiz, I'll give you the values to plug in, so you don't have to worry about that. You just have to fill out the table. And then what we're going to do is actually sketch it first. So I would suggest when you're asking or ask questions about increasing, decreasing, turning points, max and min, domain range, draw a sketch of your graph. It's easier to have a visual example to kind of pinpoint certain things that they're asking you, different characteristics of the graph, if you have it in front of you, okay? So the first thing we'll do is plug in those values. Be really careful about plugging in negative values, especially when you have a negative in front, right? My equation is negative x cubed plus 3x squared minus 4. Well, that's negative 2 cubed, but I have that negative sign out in front. Then plus 3 times negative 2 squared, then the minus 4. Well, what's negative 2 cubed? Positive or negative? Negative 2 cubed is negative 8 because it's negative 2 times negative 2, which gives you positive 4, times another negative 2, which gives you negative 8. But then I have that negative sign out in front, so it becomes a positive 8, right? You see what I mean? So it changes based off of the signs that are in front. So just keep that in mind. Negative 2 squared is 4. 4 times 3 is 12. And then I have the minus 4 on the end. What is 8 plus 12 minus 4? Somebody from home, tell me what the value is when I plug in negative 2.
Positive 36.
Not positive 36. So I have 8 plus.
Oh, wait, you mean the whole thing?
Yeah, so 8 plus 12.
Oh, okay. That's 16.
16. Good. Nice. I have negative 1 cubed plus 3 times negative 1 squared minus 4. What would be the value here? Zero. Good. Negative 1 cubed is negative 1 times negative 1 gives you 1. Then it would be plus 3 minus 4, which gives you 0. Here's a situation where we have a 0 in the f of x, right? So they give you a 0 automatically, which is nice. If you were to plug in 0, you'd get negative 4. Plug in 1, you get negative 2. Plug in 2, you get 0. And plug in 3, you get negative 4 as well. All right, you get those values from taking the x's, plugging it in, and simplifying. Okay. Like I said, I would suggest sketching the graph of this. So at negative 2, you're all the way up here at around 16. Negative 1, you're at 0. 0, you're at negative 4. 1, you're at negative 2. 2, you're at 0. 3, you're at negative 4. And just kind of sketching what the graph would look like given those values. Okay. Does anybody have any questions up until this point about what we've done so far? Okay. Part B says, determine the approximate x values for the relative max and min. Something that you're going to see tomorrow, okay? So part B says find the relative max and the relative min. Well, there's two ways that we can go about this. First way is to maybe look at the graph and determine it from there. The second way is to look at our table. Remember, if it's a relative max, I go from increasing to decreasing. So if I look at my table and I go from a number that's smaller to a large number and then back to a smaller number, that's a relative max, right? I go from increasing to decreasing. Relative min would be when I go from decreasing to increasing. So I go from a larger number, smaller number, back to a larger number. That number in the middle where I made that transition is the relative min, all right? So where do we think the relative, let's start with relative min value. Where's the x, or what x value is my relative min at? Decreasing to increasing. So decreasing to increasing. So close, not quite. So let's take a look at our table here. All right. I go from 16 to 0, so I decrease. 0 to -4, decrease. -4 to -2, I start to increase. So that transition in the middle, when I went from decreasing to increasing, occurs at x equals 0. That's where my relative min is. Then I go from -4 to -2, so I'm increasing. -2 to 0, still increasing. 0 to -4, decreasing. So the transition from increasing to decreasing occurred when x is equal to 2. That is my maximum value. Notice that visually, when x is equal to 0, that's where your min was. When x equals 2, that's where your max was, right? When we have that, we called it like hills and valleys or whatever we decided to use to describe that, that's what it would look like visually. Okay? There will be a question on finding max and min tomorrow, so just kind of keep that in mind. Any questions about part B? Part C says find the turning points. Well, turning points are a lot like the max and min, right? So where would my turning points be on this graph? What are the coordinates of the turning points? When I transition from decreasing to increasing or increasing to decreasing. Not between, so it's the min and max itself, really. So what's the coordinate of the minimum point? Good. And what's the coordinate of the max point? Ladies and gentlemen, remember that the turning points, min and max, are the same thing, right? It's that, yeah, it's the transition from increasing to decreasing, decreasing to increasing. Well, that's the same thing as what happens with the max and min, right? That's how we find that out on our table. We can do the same thing with the turning points. Part D, find the domain and range. What was always our domain for these polynomial functions up until this point? Talked about this on Tuesday. What's the domain? It's always the same. From negative infinity to positive infinity. Remember, domain is all of the x values that take place on our graph, right? Every x value that has a y. Well, for our polynomial functions, they range from all of the x values over here across my entire coordinate plane. So from negative infinity to positive infinity. My range is where my graph starts and stops in the y direction, right? From bottom to top. So domain left to right, range bottom to top. Notice that they continue in both directions for forever. So what should my range be? So negative infinity to positive infinity, because you start from the bottom and then you work your way to the top. So negative infinity to positive infinity. Okay. Any questions about part D or anything so far? We have one more question to answer. Part E says state the intervals on which the graph is increasing or decreasing. Well, remember, we use our turning points, we use our max and min to kind of help us out with this. So if I'm looking at this graph, we'll start with decreasing. We'll list both of the intervals. I start decreasing all the way over here, all the way to the left, right, of my graph. When I talk about all of the x values, all the negative x values, where do I really start? We talked about this back on Tuesday, that we're always going to include these two numbers in our increasing and decreasing intervals. Where do I technically start all the way over here in the negative direction? Not -2. So what's the most negative number ever? Infinity, right? So negative infinity, I start to decrease until I get to my first turning point. Remember, increasing and decreasing are x values. Where is that first turning point? What's the x value of this turning point here? 0. And then I start to increase between those next two turning points. Well, somebody from home, what's the interval in which I'm increasing? What's the turning point, or yeah, what's the x value of this turning point and this turning point? Where am I increasing from? It's from 0 to 2, and then I'm decreasing from 2 to infinity, right? I continue to decrease. For the sake of time, I just want to talk about the quiz for tomorrow. Remember, your assignment for tonight is to complete everything we did not do in class, which is all the evens. Quiz tomorrow, 5 questions, 20 points. There's a question about multiplying by simplifying polynomials, dividing, simplifying, synthetic division. And there's also a question about end behavior. And then there's a question that's worth quite a few points that's based off of finding zeros, maxes, and mins, all right? So make sure you take a look at the question 12 on the homework from tonight, all right? Other than that, have a great rest of your day. I will see you all tomorrow. If you have any questions about the quiz or anything from the review, please let me know over messages or however you want to reach out.